Hello everyone. So today we are going to implement our Singly linked list. Just we discussed in our last lecture, there is no implementation of a Singly linked list in a JDK, and we decided we will implement our own Singly linked list. So in today's lecture, we will discuss two methods. We will implement addFirst and the size method, and the format is same. We will do the live coding, and then after that we will come back on a whiteboard, and then we will execute, and then we will analyze the time and space of our algorithm. Before going to the live coding session, only we need to revise some concepts about the linked list. So the first thing, we will have a node. So I'm sure you guys are aware of what is node, but still. So basically in a computer memory, linked list is not a continuous memory, it's always scattered memory. So in case of a node, what we have, we always have a one data value and one always next pointer or next node. And once we will show in case of a memory, for example, we have this memory. Okay, before going to the memory, we will try to grasp this concept. So we always have a one node, for example P, and it's always saying, okay, I am pointing to one node which has a value maybe 1 and its new pointer. Okay, then next I created a one more node, and then I'm trying to assign to this one. So for example, I created node here, which is I gave the value 2, and then I'm saying okay, now this next node is all pointing to the next node. Okay, then I created a one more node 3, and now this next is going to this. So that is a concept which we can grab. But in a memory, so if we have a memory, so for example in case of an array, for example this is a 4-byte block. So if I try to do array of, for example, integer, and I ask to the operating system, hey, give me the, for example, 4 elements, so it will assign me this as a consecutive memory, and we will have, for example, this is the address. But in case of an array, in case of an linked list, we have one benefit. There are pros and cons, but the benefit is we don't care if the consecutive memory available or not. What we will do, we always get, for example, okay, this is my first node, I put some value 1 and there is null. Okay, next time I ask to the OS, hey, give me the next node, so it will say, okay, I have this available, so it will give me 2 and its address is, for example, 9, so I will put 9 here. So now in case of an array, we always have a mathematical algorithm to move our pointer by using the size. Like if I want to the third index, so I always get the first index, the memory, and then I will multiply it by the size of the data type and plus the index. So we always jump in a big O of 1 and we are on the spot. But in case of an linked list, I will get this and then I will say, okay, give me the next node address, and that will give me the next node address, then I will go here. In the same way, I am moving but one by one. So if I want to access in the last index, it means I need to move from 0 to until the last index. That's why it's mostly is big O of n. But we will see more techniques how we can improve the algorithm. So this will be the definition of a node, and this is how it works. So it's time to move towards the live coding session. Hi, welcome to the live session. So today first we will create a node class, just like we discussed in on a whiteboard,
and I'm using a Kotlin language, but I will go with the Java syntax most of the time, so there will be no issues for anyone who is good with the Java and don't know about the Kotlin. And if somewhere I need to use something specific to Kotlin, I will explain that. But again, that is not our intention. Our intention is to understand from the problem solving perspective things. So variable next node, and this is our node again t, and this is a complete thing. So basically it's pretty simple. Just like in Java we have a node which is a generic type t, then I'm saying value t, which is generic. Value means it's a read-only data type, so once you will assign the any number or anything, you are not allowed to change. Then variable next node question mark means it's nullable, so you can save null value. Plus by giving a null means I'm giving you the default argument. If someone is not providing you an argument in a constructor, please put that. And only one more thing, I'm going to use this data class. No difference. It's basically saying, okay, I'm providing you getters and setters under the hood. Okay, so like in case of a linked list, node is the internal implementation, so our client will never know how we implement it under the hood. But it's pretty good if we understand only one example. So first example, I created one node, and then I'm going to create maybe 3 are enough. So 1 2 3, and then after I've changed that value to, and then I give the link, and then 3, and again I give the link to 2, and then after that I'm saying, okay, do print all the nodes together. So now you will see in the output we have a node which value is 3, and then after that in the next node I'm giving the node which is value 2. So this is our whole node connections, and in a memory you can easily understand it's not continuously, we don't know, maybe it's continuously giving us, but still from our side we need to move one by one to, I can't jump directly to the value 1 by skipping this, I need to move. So that is our node. So we need to move towards our main topic, which is a singly linked list, and again this is a generic type, and this is our class. Now, so our implementation of the first and foremost thing, we need a pointer which will always have the start of a linked list. So for that mostly we use the term head. So I'm going to make a head which is nullable, yes, and it's t. Okay, this is done. So basically what this will do, it's saying, okay, I have a head, and if I have a value, it means linked list have some value. If not, and currently I'm not designing any constructor, so by default the default constructor is empty. So this is our head. Then next thing is we need to create a method addFirst, and in case of a addFirst, client will give us the value, and we need to add that value. So this will be the client. Maybe I can show you here. That is always good if you start thinking from the client perspective how someone will use your APIs. So if you go and try your best when you are implementing, don't use this IntelliSense. So try your best to write everything, each and every letter on your own. Don't use any IntelliSense. That will always help in the interview. But for now, I'm using so I can save some time to go faster. Okay. So this is our list, and my expectation is user will give the information. Okay, add first. So he added first 1, then maybe 2, and then 3. Okay. So add first means my head is always updated by the value. So when I'm saying add first, when there is no one, there is only one value. When user again called the add to, it means now client wants 2 is kind of a first value, kind of like a, if you know the stack, so it's basically the first value always which is on a top. So every time when you pop, you will get that. So the same concept every time. So how we should implement this? Also you need to take care of the edge cases. So first, what you know, when some client will create a linked list, it's an empty linked list. So when it's an empty linked list, it means head is null. So simple is that if head is null, then what I need to do, I need to create a new node and assign to the head, and then I need to put a value, so it will work. So now imagine only until this we ran that, and now we figure it out. Okay, add first one. So now head has a new node which is this, and its value is 1. Now the user called the second time, and this time head is not null. So when head is not null, what we need to do, again I'm sure I need to create a new node. So yep, okay, now this is the new node. What I need to do now, the current node, because it will come as a first, and then my one will be now the second. So basically I'm saying, okay, the new node, your next node should be attached by current head. So it's like 2 and then assigning to 1, and then I'm also changing my head, because at a compiler level, compiler first run the right side or for an equal operator, assignment operator, sorry, and then once it's run, it's saying okay node, and then node have the 2 is assigned, and the next one is 1, and then I'm overriding. So now head is assigned to this 2, and I think this will work. So if we do print out our list, we will see what is the result. Okay, so for this what we can do, we can override our toString method, and in this toString method we can put so this is not the part of the tutorial, but it's good. So we really want to read what values are there, and now we will try to run. Okay, so now you can see my SinglyLinkedList saying okay, I have a 3 first, then 2, and then 1, and then this is null. And by the way, how it works, basically head.toString, I'm calling this node, the first node currently, and its toString method, and this is basically kind of a recursion under the hood. So then the next ones will be called, and then the next one's toString will be called, and it's like the loop. Okay, but move towards back. Now in this case, if client asks me to give me the size of the list, what will happen? Okay, first we don't have a method, so I need to create a method first, fun size, and I need to return, this is always int. So like now you understand, it has nothing with the generic. Size is always int, or maybe long, but for now we are going with the int. And now what should I do? So I always I know, okay, I have a head. So what I can do, I can say okay, I take a one variable pointer, and then I have this. Then I will say okay, until current not equal to null, what you do, I will say if variable count equal to 0, do count plus plus, and in the end, once you are done, return me count. Okay, we will see again, is there any issue or any bug. So for example, current is I have 3 values, so current will be my third value is third, count is 0, and I am saying okay, this is not null, so I will say okay, count plus 1, and also I need to change, so I will say okay, move towards the next node, and I think I can remove it. Okay, so in this case, first is 3 node, this node, and it is not null. Yes, not null, do count plus 1. So now we have a 1, and also put current to the next node. So now I am here, then it's 2, it's not null, yes, 2, and then also move again, then I am here, and it will say okay, not null, then count is now 3, and in this case next time I do null, and when I will check current is equal to null, yes, current is null, so return this. So now if we run this method, we will try to run on 3 places, one here, then after that here, then here. So in this case we should have answers 0, 1, 2, and 3 if everything looks nice. Yes, so at this place, yeah, there is nothing. So once it will come here, it will check head is already null, so current is already null. So why I took the current and why I'm not using the head, I'm sure you understand this. So basically now once we have a list, head is pointing towards that and current is also pointing towards that, but I am moving current. If I don't take the current and I move head, then we will lose our whole linked list. So always I need a one pointer which always take the head or the first member of the variable. But now it comes towards our discussion around the analysis. So in this case, what will be the time complexity for this my size function? And it's a big O of n. N means number of nodes in a linked list. Can I improve that? Yes, we can improve that. How? Now, so this is our one. So I'm saying, okay, create maybe variable size. So I created a variable size which is initialized as 0, and in Kotlin I'm making this as a, so basically private set means this the setter method is only available inside of linked list, and the outside any client can use the getter value to access this. Okay, once this is here, I can remove this whole method. So now I'm taking a one variable who is responsible for this. Okay, then here I'm accessing this. So basically under the hood it is saying getter. It look like in Java I'm accessing directly the variable, but it's kind of a property under the hood. It's called getter. So now in this case, if I run this, there is a problem. You will see only 000 because we forgot to update. So what I need to do, I'm saying every time when this method is called, I'm sure there is a new value. So once I did this, now we will see. Ooh. So the best thing about our method now, size is the big O of 1. You have thousand or million node, we don't care. Every time when the client is called list dot size, it's a constant value because we always saying okay get the size and nothing more than that. But the previous implementation has a loop which is going one by one to everyone. So I hope you understand this. Next, can we improve this? Because in a code, once you write your first thought, it's good, but I always think if you write a good code, it always help to the interviewer to understand your knowledge. So if you see, we can improve here pretty simple. So if I write, okay, I know first time head is a null. Okay, value, we need to create a new node, and then after that I know first time head is a null, so I can do this. I hope you can understand. So if I run again this, everything should work. Yep, and maybe we can also print here list, so we can confirm our there is no edge cases which we are missing. Cool. So now you can see everything is working, but what happened? So for example, it's an empty and user called first time, like just like here one. So once I have a one, I'm sure every time this method called, I need to do two things. One new node I need to make, and size always I need to plus plus, otherwise it's kind of a edge case if you forgot. And then what next? I need to manage, I only need to manage head. So first time when head will come, head is already null, and we know first compiler will run this code and I put null here, and then after that when we assign this, now head as a first value, so this node will be there. Then the next time what will happen, we already have this node, I'm saying okay put my this node here to the new node, and then the new node assigned back to this. So by doing this we achieved our first function. So now moving back towards the whiteboard.
Okay, welcome back. I hope you enjoyed the live coding session. So now we will execute some examples and then we will see. So in our case, first use the client wants to give this input. Okay, list dot add first, and the value is 1. So under the hood we already reviewed this code. What will happen, we already have a one head and it's a new array, so it means currently it's null. And you saw in the code, when it's null we always assign a new node. So basically we assign the new node and this is referring to that node, and I will give the 1 and it's null. And also you guys remember when we discuss about the size and how we improve from big O of n to big O of 1. So it means I need to also update this size. So size value from 0 now it's 1. Okay, then user give the value of 2 like after this. So in this case what will happen, we have a new node. Just try to remember that code which we write, and then what we are saying, okay, in new node give the head. So basically it's saying, okay, give me this, and then give this new node to head. And then one more example, so we put 3. So again I'm going to create a one new node which is 3, and now what we are saying, okay, so what we need to do now, pointer this one comes to this, and then head move towards this. So as you can see, now head has a 3, then 3 has a 2, and 2 has a 1, and oh sorry, I forgot to update with this, but it's 3. So if in the end, if I ask list dot size, we are showing 3. But for example, we don't have a size element, then in that case what will happen, I will take the head and then I will put a loop while, okay, check, is it null? No. Then a local variable count 1, okay, then check next, is it null? No. Put, okay, increment 2, is it null? No. Increment, and then, so in that case it's a big O of n. But by putting only one variable, we saved our algorithm, we basically improved our algorithm from big O of n to big O of 1. So I hope you enjoyed today's tutorial. See you in the next video. Bye.